customer is usually the emulsion manufacturer, and you'll have a contractor who wants to apply microsurfacing. So he'll send us the contractor's aggregate and the asphalt that he has that he's going to use to make the emulsion. We'll do some testing on the aggregate first to make sure it meets the proper gradation and sand equivalent. Microsurfacing requires a 65 minimum sand equivalent, whereas Slurry Seal only requires 45 minimum. So we'll use either the ISSA spec, or if the contractor has a local spec, some individual states have tweaks on their specs, and so they'll send us the spec that we're trying to meet, and we'll make sure that the aggregate meets the right gradations. Then the next thing we need to do is to optimize an emulsion formulation and a mixed formulation that will allow the contractor to either pave at a certain time of year, maybe one job, or maybe use this design over the entire season. And we'll kind of try to make an emulsion formulation that's robust enough that you can use in the spring and summer. So the first thing that we need to do is make sure we have enough mix time that the contractor can get the emulsion, get the mix out of the machine, onto the road, and do any handwork that needs. So what Jennifer's doing here is she's put 103.5 grams of aggregate in there because the aggregate has 3.5 grams of moisture in it. We want to base everything on 100 grams of dry aggregate. She's put a percent of Portland of hydrated lime because this contractor likes to use lime. Some like to use cement, some likes to use lime, so we try to do what the contractor wants to do first, if it works. So she'll mix those ingredients together, and then she'll add she's added about 12% emulsion. And you can see that this mixture is not going to work for us or him. Now, if you had tried that in the field, it would be broken in the pug mill, and there'd be some shoveling going on, and nobody would be happy. So what we're going to try next is to see if there's a difference between the hydrated lime and how it mixes, and the Portland cement and how it mixes. So she's going to use the same amount of aggregate. She's going to put a percent of cement in there. Tim's messing with me. Put a percent of cement in. She's going to use the same amount of water and the same emulsion, and we'll see what kind of increased mix time we can get with that. Once we get the mix time that we need, then we'll do cohesion test, which will tell us if the material will be traffic ready in an hour, which is what we're shooting for with microsurfacing. We'll also do wet tracks to determine the minimum asphalt content that the system requires, and we'll do a loaded wheel test, which will tell us the maximum asphalt content that we can have in the system to and still avoid rutting. Okay, so Jennifer's got her aggregate in there, she's got her cement, she's adding water, and she'll put the same emulsion in as she did before, and we'll see if we get any more mix time than we did. We can't do any worse. See if we can do any better.
Break the tire down, now they grind it.
Okay, I'm running out of juice. Okay, so she's using about 12% emulsion for this. Typically, micro will start at 12, 13, 14% emulsion, and we'll do a range of those emulsion dosages. The wet track takes 6 days, and so if we do a 12% test and it fails, we've wasted 6 days to find out if the test fails and we have to start over again. So usually what we'll do is we'll do a 12, 13, 14% emulsion content while we're doing it, and then we run them all on the same day, so that we're hoping that we get one of them will pass it. Okay, she's already got 15 seconds of mix time, which is more than she got with the lime, so we've already made some progress. And she mixes pretty vigorously for those first 15 seconds because she's trying to simulate what's happening on the machine itself, and that pug mill it's given the mix a pretty vigorous stir. So she'll mix pretty vigorously for the first 15 15 or so seconds. She puts out a little bit of the material, say at 30 seconds, so that later on when she's done mixing, she can, you know, you can take a paper towel, you can pat the sample so you can get clear water if the emulsion is set and is breaking. And then she'll just kind of give it a slow stir, maybe 60 RPMs or so, because the augers in the box, the material is now made it into the spreader box, and those augers are just kind of turning over the material and moving it out to the sides of the box. So she's got about 60 or 75 seconds of mix time. So she's made it from nothing to 60 or 70 seconds, so she's made some progress here. If the contractor is doing a job that, say, on the interstate, going straight down the interstate, there's no handwork, 75 seconds might be enough mix time. As long as the material makes it out of the machine and onto the road and you can complete all of your handwork before it breaks, then that's really all the mix time you need. If you're on the interstate going straight down the road, 75 seconds might be enough. If you're in a neighborhood doing cul-de-sacs, you might need 180 seconds so that the guys can do some handwork to move the material around. So those are the kind of things that you want to communicate to the people who are doing the design, so that they know if we design for 120 seconds and you only need 75 seconds, you're going to, it's the longer mix time that you've got, the longer it's going to take to set. And so if you're interested in getting traffic back on it as quickly as possible, then you don't need that extra mix time. But if you're, again, in the neighborhood and we design for 120 seconds, you're not going to have enough time for the guys to do their handwork. So those are things that your design people need to know. Okay, so what Jennifer is doing here is she's adding the pre-wet additive that we talked about yesterday. It's called retarder sometimes. Tony had it listed as dope, so people call it different things. This is what the contractor could actually do on the machine to get a little bit more mix time. So say he had this system and he wanted it to mix a little longer. He has the emulsifier that the emulsion is made out of in an additive tank on his truck, and he can just dribble a little bit of that additive into the poke mill along with the water to increase his mix time. So she got no mix time with the lime. She got about 75 seconds or so with the cement, and now she's going to add the pre-wet. We'll see how much more mix time she can get out of the same system, adding a little bit of pre-wet to it. Okay, once we get a system that gives us enough mix time to be applied and all our handwork's done, then the next thing that we have to do is to make sure that the system sets fast enough. Microsurfacing, we're shooting for an hour or less traffic time, and the way we measure that is we take a little small ring, we put it down on some tar paper squares, and then we pour our mix in those, we level it off, and we remove the ring. We'll let that sit for 30 minutes and test it, and let another one sit for 60 minutes, and then we'll test that. What we do is we take this machine, I don't know if y'all have seen the equipment yet, but you lower that foot onto this sample, and the pressure that the sample, that the machine applies is about like a tire would apply to a pavement. And then you turn the torque wrench and you read the torque off the top of the torque wrench. So this sample gave us 12 kilogram centimeters of torque. And usually the first sample is relatively destroyed, but the sample, as long as you get 12 kilogram centimeters, you know that the sample is setting, that the emulsion is starting to break and that the material is starting to set. At 60 minutes, what we usually end up getting is the torque kind of levels off. So we got a 12 and a 15 and a 15 and a 14, and so the torque kind of levels off, and we haven't got our 20, but the sample looks pretty good. So we have a visual rating system that goes along with this as well. Okay, Jennifer's down to about a minute and a half, so we've got a little bit more mix time out of the system from the pre-wet. She only added 1%, and usually we figure that the contractor can add about 4%. We use a solution, they use the raw chemical. It's easier for us to add it to the system like this, and 4% is about the maximum that we put in the system before we start using a higher emulsifier dosage. So she's got a little bit of extra mix time out of that. The next thing that she's going to do is what would happen if the contractor got to a point where he couldn't put enough additive in the system to get the mix time that he wants, that's when he calls back to the emulsion manufacturer and he tells him, you got to slow it down for me. And so what the emulsion manufacturer will then do is take the emulsifier, put more emulsifier into his emulsion and send him that emulsifier. It'll be more stable and it'll mix longer, and then he can go back to using no additive, and as the heat of the day increases, then he can put a little bit of additive. So she's using a higher dosage of emulsifier in her emulsion in this mix. Okay, so our visual rating is 1 crack is a near spin, and that gives us a 20 kilogram centimeter equivalent. And so we can say this is traffic rate if we get a sample that looks like this in 60 minutes. This sample looks even better, has no cracks, just a little bit of aggregate and asphalt removed. We call this a spin, and we get a 23 out of this one. And then this one is even better. It's just has a little bit of the asphalt. It has been scraped off the top. We call that a solid spin, and that's a 26. So any of these, if your sample looks like any of these at 60 minutes, we say that that's traffic ready. So once we get enough mix time to make that the material will make it out of the machine, you can do all your hand work. Then we make sure that the material can be open to traffic in an hour. We're talking straight rolling, relatively, not 100 miles an hour traffic. We're talking, a little slow, and not power steering turn type traffic, but straight rolling traffic. It can go across. You can go across the lane, but you don't want to do a bunch of turning in the lane. Then we need to make sure that we have enough asphalt in the system that it will stick together. So what we do is we make 2 wet tracks to run on our wet track abrasiometer. One of them, what we do is we'll take the samples we weigh initially. We soak one for an hour. We soak the other one for 6 days. Then we run the sample underwater, and we take that abrasion head and we just run that around on the sample for like 55 minutes. We'll wash all the loose stuff off. We put it in the oven. We let it dry. And then we take the abraded weight subtracted from the original weight, and we make sure that our 1 hour wet track doesn't have more than 50 grams per square foot loss, and the 6-day doesn't have more than 75 grams per square foot loss. Then we know that we have enough asphalt in the system to keep the system stuck together. What we want to determine over here is we can have enough asphalt in the system to stick it together. But if we have too much asphalt, then the aggregate particles can actually roll on each other, so that asphalt will act like a lubricant, and the material and the aggregate particles will move, and that's when you get a rut. So if you're putting microsurfacing down in a rut, you don't want it to re-rut, and so we have to make sure that we don't have too much asphalt in there. So we make a sample that looks pretty much like this. This one's actually been run. You can see there's a little indentation here, and that's a good sample there. What you don't want to see is the material running like this. So we'll take measurements laterally and vertically, and then we measure before and after, and you'll get a percent displacement. We have a 5% maximum lateral displacement on our loaded wheel test. If it meets that, we know that we don't have too much asphalt in the system, and that it's got enough to stick together, but there's not so much that it's going to move around. Don't have any questions?
What's the difference between the 1H LM and the LM?
Well, H usually stands for a harder asphalt. So if you have a CSS1, your penetration on your emulsion residue will be like 100 to 250. If you have a CSS1H, it'll usually be like 40 to 90. So if you're paving in Georgia, you want the 40 to 90. If you're paving in Maine, you probably want the 100 to 250.
Everybody here, let's go here.
So
let's rotate. All you guys follow me.
It will tell you which asphalt to use to make your emulsion.
Because we usually use the CSS1H LM.
Right, so you're using a harder base asphalt, so you're probably taking somewhere wrong. Right. Well, the LM part is latex modified. So the H...
The H is the one that changes. The LM is latex modified.
Right.
The P is a polymer.
Right.
I got it. I remember.
Okay.
Thank you.
Hey.